Okay, so what's the real difference between a civilization like ours and one that can literally reshape its corner of the cosmos? The answer isn't what you might think. It's not philosophy or biology, it's energy. Pure, raw, cosmic scale energy. So today, let's dive into one of the most audacious, incredible ideas in all of science: how to bottle a star. To even start this conversation, you have to try and wrap your head around a fact that's, well, it's almost impossible to really grasp. Our sun, just our regular everyday star, unleashes more raw power in a single second than our entire species has used through all of our recorded history. Just let that sink in for a moment. I mean, think about it. We live right next door to a colossal fusion reactor, but we only use the tiniest fraction of energy that just happens to hit our little blue marble. The rest of it, nearly all of it, just radiates away into the void, completely lost. And this staggering cosmic wastefulness, well, that's actually the key to measuring how ambitious civilization can be. So how do you measure that kind of ambition? Well, back in the 1960s, a Soviet astronomer came up with this really fascinating framework, a sort of cosmic ladder for rating civilizations. It's called the Kardashev scale, and it doesn't rank civilizations by their art or their government or their philosophy. Nope. It ranks them by something far more fundamental: their complete mastery over energy. It was originally a way to think about what truly advanced alien life might even look like. The scale has three main stages. A Type 1 civilization has mastered all the energy sources on its home planet. We're not even there yet, probably a century or two away, best guess. A Type 3 civilization commands the energy of its entire galaxy. That's something that borders on magic to us. But the real game changer, the Great Leap, is becoming a Type 2 civilization, one that captures the entire energy output of its home star. So how in the universe would you even do that? And that brings us to what has to be the ultimate engineering project. It's a theoretical answer proposed by the brilliant physicist Freeman Dyson, and it's a concept that has absolutely captivated scientists and science fiction fans for decades. The solution is called a Dyson Sphere. The idea is simple in concept, but just staggering in its scale. You build a structure that completely surrounds your star, intercepting every single photon, every joule of energy it produces, leaving nothing to waste. But what would something like that actually look like? Now, when we hear Dyson Sphere, most of us immediately picture what we've seen in sci-fi: a giant, solid, rigid metal shell around a star. But from an engineering perspective, that's a complete nightmare. A solid sphere would be gravitationally unstable. One big asteroid hit, and the whole thing could shatter and fall into the star. So the more plausible scientific model isn't a shell at all. It's what's known as a Dyson swarm. And the swarm model just has so many advantages. It's not one giant object. Imagine billions or even trillions of independent solar collectors and habitats, all orbiting the star in a thick, coordinated cloud. You could build it piece by piece over centuries. It's way more resilient to impacts, and it can just keep growing as the civilization's energy needs grow. It's less of a single megastructure and more like an entire artificial solar system. Okay, building this is obviously far, far beyond us. But this is where the whole concept gets truly exciting for us right now. We might not be able to build one, but what if we could find one? The whole idea suddenly shifts from an engineering puzzle to a cosmic detective story. For decades, the search for extraterrestrial intelligence, or SETI, was mostly about listening, pointing giant radio dishes at the sky, hoping to hear a signal. But now, scientists are getting more and more focused on searching for technosignatures. That's any measurable physical evidence of advanced technology. And a Dyson Sphere? That would be one of the biggest, baddest technosignatures you could possibly imagine. So how would you actually spot one across the unimaginable distances of space? Well, you don't have to see the individual little collectors. Instead, you look for the massive effects that the swarm would have on its star's light. And it really comes down to two main clues we can hunt for. The first clue is an unexplained shadow. So imagine you're watching a distant star, and its light starts dipping in a really strange, irregular, and totally unnatural way. That could be the telltale sign of a dense cloud of energy collectors passing in front of the star from our point of view. It wouldn't look like a clean, simple transit of a planet. It'd be messy, a flickering shadow that hints at a colossal construction project in motion. The second clue is a suspicious glow. You see, the laws of thermodynamics apply everywhere in the universe. Any engine, even a star-sized one, has to produce waste heat. It's unavoidable. A Dyson Sphere would soak up all that useful visible light, but then it would have to radiate its waste energy away as heat. We'd see that as a huge, unusual amount of infrared radiation. We'd find a star that looks strangely dim in visible light, but is just blazing in the infrared spectrum. It's the exhaust signature of a star-sized power plant. So all of this transforms the Dyson Sphere from just a cool sci-fi concept into something way more profound. It becomes a potential message, one that isn't written in language or math, but in the fundamental laws of physics itself. It's so much more than a power plant. It's a statement. A civilization that builds one is silently announcing its presence to the rest of the cosmos, whether they mean to or not. It's a way of saying, we are here. And finding one could be the key to finally answering that ancient question, are we alone? This offers a fascinating new kind of answer to the Fermi paradox. You know, the famous question, if the universe is so big, where is everybody? Maybe the reason we haven't heard from anyone is because advanced civilizations stop shouting into the void with radio signals, and instead they just get busy building. Their industrial activity, their immense energy use, becomes their signal. And this leaves us with a truly mind-bending thought to end on. As we scan the skies, we have to consider that the first definitive proof of intelligent life might not be a friendly hello picked up by a radio telescope. It could be a strange flicker from a distant star. Not a sound, but a shadow. The quiet, irrefutable evidence of a civilization hard at work, capturing its sun.